Alright, so we are going to do some application problems here. These problems are going to look very similar to the problems you're going to see on the quiz for this module. So make sure you understand how to get the solution for each of these. Capturing some notes would be a good idea. As always, feel free to skip around in this video and watch just the problems you think you need help on. You don't need to watch the whole thing. I will put timestamps in the description so you can skip to specific problems. First one is not too bad. It is a review of just sort of a basic trig equation. And we are looking for an expression that gives the value of x. So that's a little bit different in that our answers aren't numbers, right? But we know how to do this. So what we want to do is we want to build an equation that relates these three things. So we have this angle 32 and we have the opposite side and the adjacent side. That's an O, obviously, right? So we'd say tangent of 32 degrees is equal to opposite over adjacent. And then we want to isolate x, and then what that gets us as we multiply by 14 on both sides is this, right? So that is choice C. So that's an expression for x. This is actually really useful because you may have run into this issue of like you type tangent 32 in on your calculator and you have to you get this big decimal and then you have to multiply by 14. You can actually solve a problem like this by typing just 14 times tangent 32 into your calculator and kind of avoid that problem of having to retype a big long decimal. Okay, so we went from the easiest problem on here in number 1 to probably the hardest problem on here is number 2. This is kind of an SAT style problem, but it's even harder than the version of this problem that tends to show up in the SAT. So we're given these two angles, sine A and cosine B, are equal, or there's two measures of these two angles are equal, and we want to figure out what A is. And notice, the reason this one is hard is because these are not in a triangle. They're just random angles. And you're like, what do I do with that? Well, let's think about this for a second. Sine A equals cosine B. So let's say I have a triangle, and this is A. Sine A would be, we'll call this x, and we'll call this h for hypotenuse. Sine A would be x over h. Okay? Is opposite over hypotenuse. If B is this other angle, cosine B is the same thing, right? Cosine B is adjacent over hypotenuse. Right? So what this really means, and this means of course that sine A and sine B are equal, what this really means, and this is always true if sine of an angle is equal to the cosine of a different angle, this means that A plus B has to be 90 degrees. And that's because if sine A equals cosine B, we can draw A and B as angles in a right triangle, right? So if this first angle is 90, then there is only 90 degrees left. A and B have to add up to 90 for the triangle to add up to 180. Okay? So A plus B equals 90. And I've done all the heavy lifting now, so this is now a problem you know how to solve. A plus B equals 90 and A minus B equals 12. Well, that's a system of equations. Very cool problem here. So I think the easiest way to do this one is just elimination, right? A minus B equals 90, and then 2A, not 90, right? A minus B equals 12 was my second equation. And then when I add these, 2A, my B's cancel, 102. And then I divide by 2, I get A equals 51 degrees. Okay. So this problem introduces a fact that for whatever reason the SAT people really like. The fact is this. So if sine A equals cosine B, that means A and B are complementary. And complementary is just a fancy way of saying they add up to 90 degrees. Okay, next one. This one's just very basic. Find the cotangent of theta. So SOHCAHTOA, tangent of theta would be opposite over adjacent, right? 4 over 3. Cotangent of theta is the reciprocal of that, right? So 3 over 4. That's it. And we're going to leave our answer as a fraction. Okay. Next one is we're given a point. Our point is 4, 3. So here's our line segment, and we have to find the sine of this angle. So we don't even have to find the angle, we just have to find the sine of that angle. Well, so if my x is 4, if this point is 4, 3, that means my horizontal distance is 4, my vertical distance is 3. Sine is going to be opposite over hypotenuse. So we need to find the hypotenuse yet. To do that, I'm going to do Pythagorean theorem. 3 squared plus 4 squared equals h squared, or c squared, whatever you want to call it, right? 9 plus 16 gives me 25 equals h squared, and we get 5. Okay, so 5 is my hypotenuse, and then sine q is going to be 3 over 5, opposite over hypotenuse. And we just have one more. So suppose it is known that the tangent of the angle of the crane mixed with the ground is 8 over 5. Find the cosine of this angle and leave your answer as a rationalized fraction. So here's our angle. It says the tangent is 8 over 5. So remember, tangent is opposite over adjacent. So that means 8 over 5. Okay. We want to find the cosine of this angle. So the cosine of the angle is going to be adjacent over the hypotenuse. So again, we have to find the hypotenuse. So we are going to do the same thing we did in the last one, actually. 8 squared plus 5 squared equals h squared. And then we get here 64 plus 25 equals h squared. We get 89 equals h squared. And then I take the square root of both sides. And we should check to see if we can simplify this. But 89 doesn't really factor nicely. So we're going to leave this as is. We're going to say that hypotenuse is the square root of 89. And then we want the cosine of that angle. So let's call that angle, I don't know, let's call that angle x. So we say cosine of x is adjacent 5 over hypotenuse, square root of 89. And then I need to rationalize my fraction. So I'm going to multiply times the square root of 89 on the top and bottom. And that is my cosine of x. Okay, so that is my solution as a rationalized fraction.